So today is all about solving equations, and then we're going to talk about some segments and some angles along with solving equations. So when you solve equations, you have to think about PEMDAS. Does anybody remember what PEMDAS stands for? Exponents. Very good. Parentheses, exponents, multiplication, division, addition, subtraction. Now, when you do your PEMDAS, it's kind of like a 4-step process. You do parentheses first, then exponents, multiplication and division comes together, whichever one first, left to right, and then addition, subtraction the same way. Whichever one comes first, go left to right. So when you are solving equations, the first thing that you do is you go along with PEMDAS to simplify, and then you go backwards to solve. So when you see PEMDAS, think about going forwards with PEMDAS to simplify as much as possible, and then you go backwards through PEMDAS to solve for x. Okay? So what is the first thing that we would do on problem number 1? Well, first, if we're going through, we would start with P first, which stands for parentheses. What would we do with those parentheses? Distribute. Very good. We're going to distribute that 2, because it's right outside the parenthesis, to everything inside the parenthesis. So when we distribute 2, that 5x stays, and then we get 2x minus 6. Good. And everything else would remain the same in the problem. Okay. Now your next thing that you want to do is you're still simplifying. So I don't see any exponents. I don't see any multiplication or division, but I do see some addition of like terms, like these two right here. They're on the same side, so we can put them together. So what's 5x plus 2x? 7x. So you want to simplify both sides of the equation as much as possible. So simplify the left side until you can't simplify no more. Simplify the right side until you can't simplify no more. Because can I put these two together? 7x minus 6. No, because they're not alike, right? So now we do our order of operations backwards in order to solve. So to go backwards, we still combine like terms, but now our like terms are on opposite sides. Always get your variables together first. So this 3 right here, we need to subtract it because we want to get it on the same side as the other x. So what's 7x minus 3x? 4x. And then just bring down everything else. So you bring down the minus 6, you bring down the negative 4. Now, what would you do next to get x by itself? Add 6. Very good. So I'm going to add 6 to both sides. So 4x equals positive 2. And then my last step to get x by itself is to divide by the 4. Now, when you divide by 4, think about what you're doing. You're doing 2 divided by 4. What is 2 divided by 4? 1/2, or as a decimal, 0.5. I don't care if you write it as the fraction or the decimal as long as that decimal ends. So in your calculator, when you divide things out, 2 over 4, you can say 0.5. Or, does anybody know how to change that into a fraction with your calculator? Math, enter. Yep. Math, enter will make it a reduced fraction for you. And that's a big thing that you want to make sure that you know how to use. So once you divide it out, hit math, enter. And that will give you that reduced fraction for you. Now, again, it's okay to leave it as a 0.5. But what if the number was 2/3? I don't want you to round any numbers. I want you to make it as accurate as possible, okay? So we're not going to say, oh, this is about 0.7. When we get into Math 2, Math 3, and your higher level classes, you make exact numbers. So instead of saying 0.7, we hit our Math enter and make it a 2/3. Always make it a reduced fraction, okay? But our answer for this problem is 1/2, or again, you could say 0.5. Either way is fine with me. Now, you can always double check your answer to any of these equations that you have. If you plug in 0.5 for all the x's, the left side should equal the right side. We'll do some more double checking stuff later, but that's a way to double check it by hand if you want to. All right, let's look at problem 2. What would you do in problem 2? Do the parentheses, and you would distribute. So this 18 is going to distribute to this parenthesis, but you could also go ahead and distribute the 9. All right, so 18 times x is, and then what's 18 times 4? 72. Now distribute on the right side, we get 9x plus 18, okay? Now what would you do? Subtract which one? You could subtract 18. I like to get the variables together first. So I would subtract my 9x. But yeah, subtracting 18 would also work. So get those variables together first because you may see that some things cancel out later. So what is 18 minus 9? 9x minus 72 equals 18. Okay, and then what would we do? Add the 72. So we get 9x equals 90. And last step, divide the 9. So x would equal 10. And again, you could plug it back in to double check and make sure that you got it right. Okay, let's see how you feel about equations or solving equations. So I want you guys to hold up a number, either 1 through 5, with 1 being, I do not understand anything that happened, and 5 being, I could solve these in my sleep. Okay, so how do you feel? 1, 2, 3, 4, 5. Okay, great. Okay, lots of 4s there, so that was good. All right. So let's get out our index card. And I want you guys to write this on your index card and draw this picture. So this part above the squiggly line goes on your index card, and what's after the squiggly line goes on your notebook paper. So segment addition postulate on the front, everything else there on the back, and the example on your notebook paper. All right, so on our index card, we have the segment addition postulate. So remember, like we talked about yesterday, a postulate is just a statement of fact. So it's something that's true that happens. So this postulate says if A, B, and C are collinear, what does it mean to be collinear? On the same line. Yep, that's it. Then we can add up our segments AB plus BC to equal AC. So, for example, if you wanted to add this to your index card, you can, but you don't have to. Let's say the length of AB is 5 and the length of BC is 12. So, what would be the length of AC? 17. We would just add them together. So, from A all the way to C would be 17. So, a lot of times we say this as part plus part equals whole. You can add the two parts together to make the whole piece. Or if you know the whole piece, you could subtract one of the parts to get the other part, right? Like if I know this part is 17 and this part's 12, 17 minus 12 is 5. Ta-da! That's how it works. All right, so let's look at our example. It says, let AC equal 120, AB equals 4x plus 6, and BC equals 7x plus 15. Solve for x and find A, B, and BC. Now, it doesn't give us a picture for this, but it's probably this same type of picture, right? So let's draw that picture again on our notebook paper. It's always a good idea to draw any pictures that you have. So here's A, B, and C. And it doesn't have to be drawn perfectly. Just do a quick sketch of it. Now, write down all the things that you know. So, I know that AC is 120. So, I'm going to say from here to here is 120. Then I know the distance from A to B is 4x plus 6. So, in that spot, I'm going to write 4x plus 6. And the distance from B to C is 7x plus 15. So, in that spot, I will write 7x plus 15. Now, using the property that we just had, the postulate, what would I do? Add them together to make to make 120, to make the total. So I have 4x plus 6 plus 7x plus 15 equals 120. Would anybody like to come up to the board and solve this one? Go ahead. Thank you. So add them up together and solve for x. And don't forget your equals 120. That'll make it a little bit easier. Oh, yeah. She did really good. Oh, my great. Yeah. Okay. Yeah, I just resaved it and everything, so it should be good. Thank you. All right. Good job. Did everybody else get 9? That was some good work there. Let's give him a hand. So much enthusiasm today. But yeah, we combined our like terms. So 4 and 7 makes 11. 6 and 15 make 21. Then you got to minus that 21 and divide by 11. So you get x equals 9. Any questions about that solving part? Okay, great. Now, once you know what x equals, notice there are multiple parts to this. And unfortunately, that happens in a lot of geometry. It will have one part like solve for x, and you're like, yes, I'm done. And then if you read it again, though, it says find these other things. So you're not quite done. So let's find the other pieces that we need. So we need to find AB and BC. How are we going to find those? Plug in x. So if x is 9, we would have 4 times 9 plus 6. So grab those handy dandy calculators. Do 4 times 9 plus 6 just to make sure we got the right numbers there. Or you can trust your mental math skills. Either way, I don't trust mine. And you get 42. Okay, so that means the length of this segment's 42. We're plugging into this one as well. 7 times 9 plus 15. A little hand trick for the nines. And what did you get? 78? 78. If you added those two together, would you get 120? Then that's how you know that you did it right. Now, one thing that you may want to do is write your answers to the side. That way you know what's what. So label them on your graph is good or your line that you have, but also label to the side. Length of AB is 42. Length of BC is 78. And then x equals 9. I always like to circle my answers. That way I know where they're at, and that might be a good thing for you to do as well. Any questions on how to solve this problem? Okay, let's talk about one more thing with segments, and then we're going to talk about some angles next. These two things will go on your index card. Like how they're underlined. I'm trying to go with a theme here. If I underline it. And you can put them on the same one because they're pretty much the similar definitions. So midpoint and segment bisector can go on the front. And then on the back, put everything else. It's what it reminded me of. Now, while you're writing these definitions, you might notice that these two things are actually the same thing, right? Think about what a midpoint is. Y'all talked about midpoint back in Math 1 when you were looking at a coordinate plane. What did a midpoint do? It's telling you what the center is. It's telling you what the middle is. It's the halfway point. That's right. So it's the same thing when you look at geometry terms. It's your halfway point. It's your center. A segment bisector does the same thing as well. It cuts something in half. So just remember that these two terms, when you see the word bisector or midpoint, they basically mean the same thing. They're saying that they're finding the middle point, and there's two equal parts on one side and the other. Now, when you get into geometry a little bit more, you don't use the word equal as much, but you use the word congruent. Congruent is just another word for equals. Now, down here on the graph, you see these two little marks here and here. Those also mean congruent pieces. So if you see little vertical red marks, it means that things are equal to each other. Sometimes it's just one line, and sometimes it's two lines. So this is saying that AB is equal to BC. So AB is equal to BC. So you can either see the marks, or it has to say the word midpoint or bisector. Now, in this little box, it says line L. That's a cursive L. Kind of looks like an E, though. So if you said it was an E, that's fine, too. So line L is a segment bisector of AC. So this line bisects that segment. And B is the midpoint of that segment. Again, means all the same thing. You would set those two parts equal to each other. So guess what we're going to do in the next example? Close. Yeah, actually we're going to do a little bit of midpoint, then we're going to do angle addition. All of this also applies to angles that we've just talked about, so that's what we'll do next. I had a lot of people ask me in Math 3, they'd be like, how many slides does it say right there? Because that's how many we go through, so it does say 9. So we're on slide 4 of 9. But the last slide always talks about homework, so there's really only 8. And the first one always talks about homework questions, so there's really only 7. So we're on 4 out of 7. Actually, 3 out of 7. It doesn't matter. We're about halfway. Y'all are not falling asleep yet, so that's good. All right, let's do an example. So write down this picture and definitely write down that sentence, because if you don't have that sentence, then it's not going to be very helpful. So this is back to your notebook paper. So putting this example on your notebook paper, draw that line, write that sentence. All right, keywords down here at the bottom. Q is the midpoint. So if Q is the midpoint, then that hits in the middle. And again, you can make these two little lines right here showing that that segment is equal to the other segment. So if you see the red lines or see this word midpoint, it means that these two parts are equal to each other. So PQ is equal to QR. So if we're setting up an equation, we just set those two parts equal to each other. 6x minus 7 equals 5x plus 1. And now we have a simple equation that we need to solve. What would you do first to solve this equation? Good. Subtract the 5x. Very good. Get your like terms together. So we end up with 1x, or just x, minus 7 equals 1. Then your last step would be to add the 7. We don't need to do anything else because that's just a 1x, or just x by itself. So x would equal 8. Now remember, like I said, there's usually more things that you have to do on these problems. So the problem says if Q is the midpoint of PR, find, this little m means the measure. So we want to find the measure of PR. So that means the whole length from P to R. So what should we do to find that length? Good. Plug it back in for the X. So 6 times 8 minus 7. And then you could do 5 times 8 plus 1. What should happen when you plug 8 back in for both of those? They should both equal the same thing. They both equal 41. 41 and 41. So what is the measure of PR? 82. And that would be your final answer. So be careful on tonight's homework because it won't just say find X. It may ask you for additional things from there. How do y'all feel about segment addition and solving equations? Good. Well, if you ever need help with solving equations or have any questions, make sure that you ask. All right, now we're on to our third index card. This is our final one for the day, right? Okay, on the front, you can write types of angles on the front, or angle types, either way, types of angles, angle types. So our next 2 slides, we're going to talk about angles that we have and how to work with those. I guess 3 slides, 6, 7, 8. All right, so there are 4 types of angles that we talk about: acute, right, obtuse, and straight. Draw those just real small at the top because I also want you to put congruent angles on this card too. So you have all of this goes on the back of your index card. Y'all probably know those angle types, right? Y'all remember acute angles? What's an acute angle? Less than 90. Good. Up there, it says 0 is less than X, which is less than 90. It just means it's somewhere between 0 and 90 degrees. We say less than 90 because we haven't learned about negative angles yet, but you'll learn about those in Math 3. Dun, dun, dun. Preview. And then what's a right angle? Definitely equal to 90. Good. And you may see that little box there in the corner for a 90-degree angle. Okay. What's an obtuse angle? More than 90, but less than 180. And I don't know if we do more than 180 too much in Math 2, but you will in Math 3. So an obtuse angle is more than 90, but less than 180. And a straight angle is one that equals 180 because it makes a straight line. So anything that makes a straight line would end up being 180 degrees. The only one that you can assume is a straight angle. You cannot assume that something is exactly 90 degrees unless it has that little box there, because there's not much difference between 89 degrees, 90 degrees, and 91 degrees. It barely moves, and so it's hard for the human eye to tell. So you cannot assume a 90-degree angle. It has to have the little box, or it has to tell you. But a straight angle, we can assume that it's 180 degrees. So those are your 4 types of angles. Y'all talked about those, what, in elementary school maybe? I'm trying to think. My daughter's in 5th grade. I guess they've talked about angles. My daughter asked me one time, we were talking about, like, you know, things and how old things were. And she said, were things in color when you were little? And I thought she meant the TV. She meant actual colors of the world. And I was like, what? And she goes, oh, never mind. That's a dumb question. I was like, yeah, it is. You know how some people say there's no such thing as a dumb question? There are. That one was dumb. Were there colors when you were little? Yes. The sky was still blue. Oh, it's funny. Fun times. All right, the last thing on your index card is these congruent angles. Remember, another word for congruent is equal. So congruent angles are equal angles. They have the same measurement. Now, when you see them, like with the lines, we put little vertical red marks. When you see these little curves here, these mean that those angles are equal to each other. So down here is two different types of notation that you will see. The measure of angle A is equal to the measure of angle B. And then you have this symbol here. That's kind of hard to see, so I'll draw it a little bit bigger. If you see an equal sign with a squiggle over top, that means congruent. So an equals with a squiggle over top means congruent. When we get more into geometry, we can use proper notation, but if you just put an equal sign, it will mean the same thing. But congruent means that the angles are exactly the same. Equals means that they have the same measurement. So it gives you kind of a little different meaning, but not really much for us. Now, the other two index cards that you have, I want you to go back to those. You had your segment addition postulate, and then you had your midpoint and segment bisector. At the very bottom of both of those, put a little star and put applies to angles. So the segment addition and the midpoint bisector also applies to angles. So angles will work along with both of those. Now the key thing with angles is they won't say the midpoint angle, but they will say an angle bisector. Okay, so the other two index cards applies to angles. All right, let's do our two examples, and then you guys will have a chance to do some homework. So here is our next one. Draw that picture and write down all that fun stuff. Now, when you name angles, you have to use 3 letters. The 3 letters will help determine how far the angle opens up and kind of what it looks like. The middle letter is always the vertex. That's where your two sides come together of your angle. So when we talk about angle WXY, we go from W to X and then to Y. So it's talking about this top angle here. So go ahead and write that angle in your picture. The measure of that angle is 4x minus 20. Then when it talks about the next angle, yxz, you go from y to x to z. So you're just looking at this part to the right. So the measure of that angle is 3x plus 14. Now when it talks about angle WXZ, you start at W, then go to X, and then go to Z. So that's actually the entire thing, the whole part. So when you have a whole part, sometimes I do it on the outside and I just make a big kind of loop and say the measure of that part is 155. So what would we set up to help us solve for X? Very good. You would do part plus part equals whole. You add the two parts together to make the whole thing. Just like our segment addition postulate. Part plus part equals whole. And then we just add up our like terms and go through and solve. So 4 and 3 make 7. So 7x. And we have a negative 20 and a positive 14. That would give us negative 6 equals 155. So remember, solving equations, combined up those like terms on the same side first, and then keep going to solve. So next you would add 6. So 7x equals 161. And then you would divide by 7. What do we get when we divide by 7? 23. It's nice that it ends in a nice whole number. I tried to make them nice whole numbers, but it doesn't always work out. Okay, so don't forget to go back and look at the question, because the question says find x and the measure of angle WXZ. I don't know why I put WXZ. It was supposed to be WXY. My bad. Let's change that last one to a Y, because we already know WXZ is what? 155. So we want to find the measure of angle WXY. So in order to do that, we would just plug in 23 for x. So let's do 4 times 23 minus 20. And somebody with a calculator can do that for me. Huh? 72. So the measure of that part would be 72 degrees, or if you just put 72, that's okay if you forget the degree symbol, because that's obviously an angle. Now you could also plug in 23 back for this x to make sure that you get a number that when you add it to 72 that you would end up with 155. So great way to double check yourself to make sure you got the right stuff. All right, y'all ready for the last problem? Yippee! Okay, copy down this picture and write those words. Solve for x. Now this is the only picture that we have. We don't have any other information. It just says solve for x2. What do you think we should do? Perfect. We're going to set these two equal to each other. There are two ways that you know. First way, it doesn't give you any other information. So the only thing that you can do is set them equal to each other. And the second way, good, is knowing that we have these little marks right here. When you see those little marks, even if they're not in red, it does mean that those two are congruent to each other, which means that they are equal. Okay, what would you do to solve this equation? Subtract 2x. So 2x minus 2 equals 14. And then you would Add 2. 14 and 2 make. And last. So x would be, good. And it didn't tell us to plug it back in to solve for the different pieces, but you could plug it back in just to make sure that the pieces are equal to each other. Okay, now when you do tonight's homework, there's a lot of solving equations because that's what we did a lot in our notes, right? You do not have to show these steps that are in different colors, but you should show some logical steps. For example, if this was the question and you didn't show any of this and you just wrote x equals 8, I'm going to count that problem wrong. You're not going to get credit for it at all. So you have to show these steps. Now again, you don't have to show the things that are in color there. So if you just wrote what's in black up here on the board, that will give you credit. Does that make sense? Okay, another thing too is I will be walking around with the answer key, so I may look over your shoulder just to spot check and make sure that you're doing it correct. If you want to look at the answer key at any point to kind of see if you're doing it right, just call me over and be like, hey, can I check number 20? And I'll be like, yeah, sure. And we're kind of check it together and make sure that you have it correct, okay? If you finish the homework early, you're more than welcome to turn it into the box in the back of the room, or you can save it until the next day when we go over homework questions so you can kind of spot check too. And don't forget about last night's homework. It's also due tomorrow. So last night's homework and what you have tonight, both due tomorrow. Okay, and there's the homework. It's on Canvas just like last night, looking at that homework page.